maybe or maybe not, you learned all of these different algebraic properties of equality when you were solving equations. So for example, if you had a one-step equation that looked like this, x plus 3 is equal to 5, how would you solve it?
5 minus 3.
You would subtract 3 from both sides, right? And then we would get x is equal to 2. What if it was x minus 3 is equal to 5? Then what would you do?
Add.
And you would add 3 to both sides. Get your x is equal to 8. If it was, stuff all over the place up here. If it was 3x is equal to 5, what would you do?
Divide.
You would divide both sides by 3 and get x is equal to 5/3. And if it was x divided by 3 is equal to 5, what would you do?
Multiply.
And you would multiply by 3 on both sides to get x is equal to 15, right? So we know how to do that. It's nothing new. Hopefully, nothing new. So now we're putting it into property form. So I'm going to write these out as if-then statements. So your algebraic addition of property of equality says, if you have a number A equal to B, then it must be true that if I add some number C to both sides, it will stay equal. I got witch's hair in my mouth. Okay, so addition property. So up here, I had x minus 3 is equal to 5, right? So I had a left set equal to the right. So what the addition property of equality says is as long as you add that same number to both sides of the equal sign, it should still stay equal. If we put it in general terms, does 2 equal 2?
Yeah.
Yes. If I add 3 to both sides, do I still have an equal statement?
Yeah.
Yeah, 2 plus 3 is still equal to 2 plus 3. Okay, so your addition property of equality. I don't know if you guys were taught in middle school, like the balance. You have to keep things balanced on both sides of the equal sign. Maybe they had you draw a line straight down the equal sign so that you only did one thing to one side and the other thing to the other. All of those different rules there. Okay, so the same thing holds true for subtraction. So if A is equal to B, then it also must be true that I can subtract some number C from both sides and it will still stay equal. Multiplication, again, if A is equal to B, then it must be true that A times C is equal to B times C. And then division is still the same thing. So if A is equal to B, then A over C is going to be the same as B over C. And then I'll put the substitution one at the top so people in the back can see it. So what does it mean to substitute something? I had a substitute the other day. What did that mean?
You put something
In place of
before
something,
else.
right? Okay. So if, this goes in the substitution box, I'm just putting it up top here so you guys can see. So if it's true that A is equal to B, then you can substitute, oops, running out of space. Go down here. Substitute B for A in any expression. Okay, so substituting something in place. So if we take it back to our algebraic concepts, we go back to this equation right here. There was a step that you probably learned back when you solved equations to go back and check your work. Remember doing checks? Well, when you did a check, what did you do? You substituted your 2 back in place of x to see if you had a true statement, right? So simplifying that got you 5 is equal to 5. Does 5 equal 5? Yes. So you know that you did it right. Right? So substituting something in place of something. That's how you did it algebraically. All right, so now what's going to happen is we're going to formalize this into a proof. And all these steps are not there for you, which I didn't want them to, so I'm going to erase them on my side. So now what's going to happen is you're going to have an equation that you're going to have to solve, but we are going to organize our steps in what's called a 2-column proof. Okay, and I have the 2-column proof already provided there for you. So it kind of just looks like a T-chart. Get rid of these lines over here. So when we solve this equation for x, we're going to do all of our solving on the left-hand side, but then over here on the right-hand side, we're going to have to put all of our separate reasons for it. Okay, so your first line should always, always, always be, so I'm going to put a little 1 here in front. First line should always, always be what's given to you, the equation. So then over here on the right-hand side, I'm going to write given. Okay, so if that was the equation you had to solve, what would you guys do first?
I'd probably put my x's together.
You'd move the x's. I would move x's too. You might not move x's first. You might move the constants first, and that's up to you on what you do. Me personally, I like to bring my x's together. So I have a positive 3x and a negative 4x. Negative 4x is the smallest. So the opposite of a negative 4x would be to add 4x. So then what I'm going to do is I'm going to do a little plus 4x, and then I'm going to extend the whole entire line all the way across. So my second line, so line 2, would be what? So 3x plus 4x combines to make 7x. Bring down that plus 8, bring down the equals. My negative 4x and my 4x would go away to negative 34. So what property did we just do to both sides? Addition, subtraction, multiplication, addition, right? So over on this side, for my line 2 for reasons, so why can I get that? Well, I just did the addition property of equality. And you can just put PO for property of equality. So the addition PO. Okay. Then what's your next move? Yeah, so I'm going to subtract 8 from both sides, and I'm going to put a line. And those lines aren't necessary. I just put them there to kind of organize my thoughts. So line 3, when we simplify that, the 7x comes down, your 8 goes away. Negative 34 and negative 8 is negative 42. So what property do we just do now? Subtraction, good. It's easy because it's just whatever it is, the operation of that you're doing. So subtraction PO. And then what's our next move?
Divide by 7.
Good, so I'm going to do a divide by 7, put a line. So line 4 should be x is equal to negative 6. What property? Division, good. So now we're just solving equations. But we're organizing our steps, and we're justifying each step by a property of why we can do what we can do. Okay, so this is a formalized proof, just in algebraic form. Okay, so if you flip on the back, we're going to add another property to the mix. Remember the distributive property? So your distributive property looks something like this. If you have A times the quantity B plus C, what do you get when you distribute that through?
B times A plus C plus C times A.
Yeah, I'm just going to put it in alphabetical order, but that's totally right. Don't forget, students always will forget this second distribution, right? Don't forget to distribute it all the way through to the first and to the last. Okay, so now we're going to do another formalized algebraic proof. This time we're going to have a distributive property involved. Okay. All right, so set up your T-chart if it's not there. So T-chart it up. I'm going to put statements as the title of my left column and reasons as the title of my right column. And then line 1 is your given. So what am I given? I'm given the equation of 60 equals negative 3 times 8x minus 4. Given. All right. So, what's next?
Distribute.
Distribute. Good. So I'm going to put a line. So line 2, 60 doesn't change. The equal doesn't change. When I distribute that -3 through, we get negative 24x plus 12. Because -3 times -4. And then on the right-hand side, I'm going to put distributive property. What's your next move?
Subtract.
Good. So -12, put your line all the way across. So line 3, 60 minus 12 is 48 equals -24x. What property is that? Subtraction, good. So subtraction, and what's our last move? Divide by -24. Put your line. So we get -2 is equal to x, which is division, property of equality. Okay, and we get x by itself, so we're all done. Questions with any of that? So we remember how to solve equations? Remember how to solve equations with the distributive property, hopefully? All right, so now we're going to add in our geometry component. So we're going to go back to our chapter 1 days. So do we remember doing angle addition and segment addition?
No.
What was angle addition? Adding angles. Yeah, hence the angle addition, right? So if you had something like this, A, B, C, D, and this was 30 degrees and this was 10 degrees, what would be the measure of angle ABD, or ABC? 40, right? Because I would just add them together. So the big angle is equal to the two little angles combined, is our angle addition. Okay, so down here for angle addition, let's write the measure of angle ABC, so that's your big angle, is equal to the measure of angle ABD plus the measure of angle DBC. So your big is equal to the smalls. Add it together. If I change this to segment addition, so turning from angles to segments, here we have A, B, C. If this was 10 and this was 30, what would be the length of AC? Oops.
40.
Yeah, 40, right? Because we just add them together. I don't want this up there. Okay, so segment addition tells us that the big segment, so the whole thing, is equal to the two small parts added together. AC is equal to AB plus BC. Okay, so now we're going to add in a component of angle addition or segment addition, depending on what the diagram is giving you, which then should take us to the algebra components. We're going to blend them all together. Okay, all right, so the last proof on your notes is right here. Good job if anybody started making their T-chart. So T-chart, statements on the left, reasons on the right. So now instead of being given an equation, I see the word given, and directly following it tells me the measure of angle AOC. Is that the big angle or one of the small ones?
Big angle.
The big angle, right? So we're given the big angle. So I'm going to write here at line 1 exactly what follows the word given, which is the measure of angle AOC is equal to 139 degrees. Given. Okay. So if we were back in chapter 1, what would you guys do for solving this out for x? What would be your equation that you would set up?
2x plus 10 plus x equals 139.
Yeah, do you guys remember doing that? Right, and we'd solve it out. So then we would combine like terms and get 3x plus 10 is equal to 139. Then we would subtract and get 3x is equal to 129. And then we would divide and get 43 for our x, right? That's what we did back in chapter 1. So now I need to put it in a formal proof. But before I can get to the algebra, my line 2 is going to be my angle addition line. Or if it was a segment, then it would be a segment addition for line 2. In this case, I have angles, so it's going to be angles. So what does angle addition tell us? Well, angle addition tells us that the big angle, which in this case is AOC, so the measure of angle AOC is equal to the two small ones added together. So give me one of the small ones. Well, in letters, name it first.
Angle x.
Well, what is the angle name? So AOB. So the measure of angle AOB plus the other one, which is BOC. So angle addition is what tells me that I can do this. Now for line 3, well, what is the measure of angle AOC? What did we say it was? 139. What property lets me put something in place of something? Substitution, right? Is equal to, well, what is the measure of angle AOB up there in the diagram? X. BOC is 2x plus 10. So what did we just do? Well, we substituted actual values in place of the angles. So that's the substitution property. Now let's solve it. Well, I already did solve it, so let's just solve it over here. So what's our next move? Combine those like terms. So 139 is equal to 3x plus 10. Over here, whenever you combine like terms or you evaluate something, you can just write the word simplify. It's kind of the go-to. If you wrote out combine like terms, I would accept that. Okay, so now we have, here I'll go up higher so people can see in the back. Does everybody at least have line 2? All right, so line 4 combined our like terms. So line 5, what would be your next move?
Subtract 10.
Subtract 10. So when I subtract 10, what do I get?
129 equals 3x.
Good. 129 is equal to 3x, and I guess I'm not doing my lines. Forgot to do that. If you're doing that, great. If not, it's okay too. So what did we do? We did the subtraction property of equality, so subtraction po. And what's next? Divide by 3. So line 6 is going to be 43 is equal to x, which was the division property of equality. Okay, so all we're doing is we're just adding in the extra element of angle addition or segment addition. If this problem would have been a segment instead, give us a second to finish getting this down and then I'll erase it. So if this would have been, as my diagram instead, so AC, B, X, was it 2x plus 10? Is that what it was? So if we were given AC is equal to 139 and we needed to prove that x was equal to 43, what would be the only thing that would have changed? Well, my given would have been AC is equal to 139 instead. And then what would the second line have been? Would have been angle or segment addition? Segment addition, because I have segments. And then what would the left have looked like for segment addition? The big, what's the big? The whole thing
AC
is equal to,
2x plus,
well, AB
oh yeah.
plus BC. Then we would substitute in 139 is equal to x plus 2, x plus 10, because of substitution. And then all the rest would be exactly the same, right? Okay, so angle addition or segment addition. Questions? All right.